So a transformation is exactly what it sounds like. It transforms vectors or figures from their original locations into a new location. For instance, let's say we're given a vector in R2 space. We could apply a transformation that shifts it up and to the right, moving it from its original location to its new location. When it comes to linear algebra, transformations are interesting to us because we can actually express them as matrices. For example, if we want to reflect every vector in a set, first across the x-axis, then stretch it horizontally by a factor of 2, and then maybe rotate it 45 degrees, we can group together all of those transformations into one transformation matrix. Then to transform any vector that way, we just multiply the transformation matrix by that vector that we want to transform. So in this section, we'll explore everything about transformations, including linear transformations and their properties. Let's get started with an overview of transformations and how they act like functions, and then later we'll get into linear transformations and projections and compositions.